Listen and look.
The essential understanding for this lesson is: line plots are one way to organize and represent numerical data collected in a survey. You can use line plots to answer questions about a data set. Previously, students recorded measurement data in line plots with whole number and fractional units. They also analyzed the data displayed in line plots to answer questions about the data. In this lesson, they extend their work to answering more complex questions about data displayed in line plots. This problem is key because students use what they know about reading line plots to answer a question about a data set. This requires solving a multi-step problem. Listen and look for students who count and compare the number of different amounts of cheese that were ordered. They count 3 amounts that are 3/4 pound or less, and 2 amounts that are 1 pound or more, noticing that there were no orders for 1 and 1/4 pounds. Then they subtract the number of different amounts to find that there was 1 more order for 3/4 pound of cheese or less. These students do not show an understanding of how to read a line plot. Point out to these students that the title of the line plot tells that each X represents 1 order for cheese. The label for the scale tells the different amounts of cheese that were in the orders. So, to compare the numbers of orders for cheese, the number of X's needs to be compared. Listen and look for other students who do count the number of X's to find the number of orders for cheese. They count the X's above 1/4, 1/2, and 3/4 to find that there were 9 orders for cheese that were for 3/4 pound or less. Then they count the X's above 1 and above 1 and 1/2 to find that there were 3 orders for cheese that were 1 pound or more. Finally, they subtract the numbers of orders to find that 6 more orders were placed for 3/4 pound or less than for 1 pound or more. These students show that they are increasing their understanding of how to use line plots to answer questions about a data set. This understanding will help them later as they solve word problems using data displayed in line plots.
Okay. Now we listen to another video for more understanding.
How can you analyze data displayed in a line plot? A line plot, or dot plot, shows data along a number line. Each dot, or X, represents one value in the data set. In science class, Abby and her classmates performed an experiment in which they used different amounts of vinegar. The table shows how much vinegar each person used.
Wow, science is fun!
Why would you make a data table? What kind of information is recorded in the data table? You make a data table to organize and record information. This data table shows the cups of vinegar used by each person in an experiment. A line plot shows how often each value occurs. This line plot can be used to organize the amount of vinegar each person used. Read the line plot. What do the columns of dots represent? The columns of dots represent the amount of vinegar each student used. How many students took part in the experiment?
Select your answer.
Okay, now we count the number of dots, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, okay? Time. Now the number of students share in this survey, 21 students. How many lab equipments here? Now we have 1 over 2, 3 over 4, 1, 1 and 1 over 4, 1 and a half, and 3. When I ask which is more often it means which is more common or most repeated. At 1, there are more dots, more than any dots here. When I ask about the least repeated or the least often, yes, at 3 caps, so one dot also, 1 dot only, okay? We can represent by dot, or instead of dots we can represent by axes, okay?
21 students took part in the experiment. Analyze the data. Identify any outliers. An outlier is any value that is very different from the rest of the values. What is the outlier in the data set?
What is the meaning of outlier? Outlier, it means a different one for the total. Here have 3 over 4, 1 and 1 over 4 and 1 and a half more close to each other, and the 3 is distinct or far from all data, so 3 is outlier. Okay, maybe the problem doesn't contain outlier. Okay, maybe all dots at whole number and only one at fraction, so the fraction is outlier, and so on.
The dot above 3 is far from the rest of the dots in the line plot, so 3 is an outlier in this data set. Now you know how to analyze data displayed in a line plot.
So our lesson, how to read the data or information on line plots. How to interpret each one does it mean, okay? When I asked about the number of dots more than 1, so we count the numbers of dots after 1. 1, 2, 3, 4, 5, and 6. When I ask about the number of dots at 3 over 4 or less, so we count at 3 over 4 and less than 3 over 4, and so on. Okay, now we move to the practical part. See you. Hi guys, now the practical part. Open your book page 701 and please concentrate. Our lesson today about the plots. Okay, line plots means we have data and we represent this data by axes or plots. Okay, this example for order of cheese. At quarter 1 over 4, 2. At half 1, 2, 3, 4. There are 4. 3 over 4, 3. And 1, 2, and 1 over 1 and 1 over 4, nothing, and 1 and a half, 2. Okay, how many orders of cheese? He asked about the total number of x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the total number equal 30. The most often. What is the most often? Most often, the most repeated. Okay, the number has greater axes. Okay, here 4 axes at what? At half. So the most often at half. Okay, now number 8, 3 over 4 or less, and more than 1 or more. We have 2 parts of the question. 3 over 4 or less. 3 over 4 or less, 3 over 4, we count 3 over 4, 1, 2, 3, or less than 3 over 4, towards left. Now we count 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9. More than, it means difference, it means minus. 1 or more. At 1, 2 or more, yes, 4. I think this is 3, not 4. So 9 minus 3 equal 6. So here the total number equal 12, not equal 13. Again, the total number of axes we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, the most often, which number has greater number of x's? Yes, have. And 3 over 4 or less. 3 over 4, we count 3 over 4 and less than 3 over 4 toward the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. So have 9. And 1 or more, 1 and towards right, 1 equal 3. 9 minus 3 equal 6. Okay, if he asked about the outlier, it's a different number for the other's number. Look here, 1.5. Okay, yes, far from the total numbers at 1 over 4 to 1. So 1.5 is outlier. Maybe the data hasn't any outlier. If there is a number here, so there is no outlier. Maybe outlier different in the number. Okay, maybe all numbers at fractions and one number at a whole number, like this one. Okay, so one is outlier because all data here is at fractions, but one is only whole number, so one is outlier. So we can say one is outlier because one is a whole and all numbers are fractions, or 1.5 is outlier because 1.5 is a distinct or far from all data. Okay, thank you.